right, well, welcome back, and we're going to be talking about section lesson 9.1D and the power of the test. I've got the power of the test. All right, well, if you've been following along with my class and been doing some other tutorial videos, we've discussed starting in chapter 9 about me shooting free throws. Okay, I take a lot of this stuff from Stats Medics, so thank you, um, uh, Luke and that group, Mrs. Gaius. But I'm going to change this to Mr. Gutchuk. So recall that Mr. Gutchuk claims he is 80% free throw shooter. His AP stats class is skeptical and believes that he is less than 80% free throw shooter. Mr. Gutchuk has decided to take another SRS of 50 free throws to prove himself. Okay, so in this chapter, we talk about hypothesis testing. So write an appropriate hypothesis for the significance test. Well, first off, we're going to have a null hypothesis. So this is our null. And we're going to say, we're going to assume that I am an 80% free throw shooter. Okay. And so what we're talking about is our p-value is the true proportion of free throws made. Free throws made. All right. Okay. And our alternative is that actually we found that that I actually may be less than 80%. So we have an alternative hypothesis right here. Okay. So we want to figure out the true proportion of free throws made by Mr. Gutchuk. Okay. What is my true free throw percentage? Okay. Well, a type 2 error in this setting would be if we would fail to reject the null, but the alternative hypothesis is true. Okay, and so essentially that is what's happening here. So essentially that I failed to reject null, so we believe Mr. Gutchuk, I'll just call Mr. G, or I am a 80% free throw shooter. But I am less than that. All right. So essentially, I'm worse. Okay. So that's what we have there. And so that's what that's what the type 2 error is. So we failed to reject the null, but actually the alternative is true. That would be a type 2 error. Well, let's go and try to test out all this stuff. And you see that I have an applet over here if you're wondering what this all is, because we're going to test the error and power of insignificant testing. So suppose that I am a free throw shooter percentage is actually 66. So let's say this is true. Type 2 error is true. So I am actually a 66% free throw shooter. Okay, that is the alternative is true. We're going to enter in all the information into this little applet. So if you want to copy this down, you can follow along and try this out yourself. Now here, click the display of type 2 error. It is shown by the blue shaded region. So we're going to say we're going to have type 2 error. I'm going to just display this other stuff. Okay, and so we're going to go and look at this. So if we go down here, we had a sample size of 50. Type 1 error, we're going to say is, let's say it as a 95%. So we're going to go at an alpha value of 0.05. And we're going to go down here. And what we see in this region is if our alternative is true, what is the probability of type 2 error, a bad decision taking place? So looking at this, we can see our type 2 error is 0.24, all right, value or 24%. Okay, and that's what we have there, all right, 24%. Well, if the alternative is true, what would be the probability of a good decision here? Well, a good decision would be that we would actually reject the null because the alternative is true. So a good decision would actually we reject the null. Okay. Well, what is value of that? Well, actually, that is what's known as the power of the test, where we successfully reject the null, okay? And that is what's known as the power. And you can see the power of the test right there, okay, is 76%, okay, 76%, okay, 76%, or 0.76. Now, how can you get the power of the test? Well, in right here, if alternate is true, what's the probability of getting type 2 error? Well, in order to get the power of the test really is equal to 1 minus the type 2 error. Okay, and that's how we can get that value. All right there. Now, if we interpret this, the probability of a good decision in the context of the problem, essentially what we're saying is um, if Mr. Gutjock or myself, Mr. G, um, has a 66% free throws percentage, okay? If Michigan, or maybe I could say, if Michigan is, Mr. G is a 66% free throw shooter, all right? That'd probably be better, free throw shooter. I'm sorry if you can't read this very well. My writing is horrible, all right? Free throw, I'll try to write better, throw shooter. Then probability of correctly rejecting the null is, and that's where we have the power of the test, is 76%. Okay, and that's what we know. So if, all right, the alternate is true, so if I am actually a 66 free throw shooter, then the probability of correctly rejecting null is 76%. And that is what we refer to as as I said before, I've got the power of the test, okay? And so this is really talking about the power of the test. Okay, that's what we have there. Now, the question is, how do you get that power percentage? Well, this is actually what you do, is that if we take this, all right, value, and let's just say, I'm just going to copy down these two different curves. So if you take those, and let's say I have the blue, all right, so this blue is actually the alternative, okay? And in this one, we say, all right, the true p-value is actually equal to 0.66, okay? So that's why it's 0.66. All right, and then we have another value over here. And this is what we think to be true. So I'm just gonna make this a little bit bigger. All right, let me get this right here. And we believe the p-value in this one is 0.8, okay? Because I said it was 0.8, but obviously exaggerating a little bit. And so now the question is, where do we find this power? Now the power, if we go back up here, okay, is referring to this green value. So how do we figure out this probability? Well, if you notice right here, there is a point, okay? There's a point where we would actually reject it from what we believe to be true, okay? Because if we said this is 0.5, 0.05, okay, there is some sort of point right here where we start rejecting the values, okay? We can see over here, this is where, all right, 0.66 or whatever the mean is, and actually I probably drew this a little bit inaccurately, all right, so wherever the mean value is right there, okay? And so let's just say 0.66 is somewhere over here, this is gonna be 0.8, all right, 0.8, all right, is actually the probability, and so 0.66 would stay right there, so when we have this going up and then down, all right, goes like so, okay? So that is our value, so I apologize for trying that kind of poorly. Make that blue again. All right, and so there is a point right here, and this is going to be 0.66, um, that we have this value, and obviously we will fail to reject the null, right? However, there is, what is the probability of actually correctly doing this? Well, knowing that the alternative is true, the alternative true, okay, um, what we are going to do is we're going to try to figure out, okay, what is the area? All right, what is the probability? What is all of this shaded region in our other value? What would that be? Okay, what would that be? What would be the probability if we were going through and finding out this? So what we have to do is we have to figure out, okay, what is that value? What is the percentage that we need in order to where we actually start rejecting null? So we need to figure out that p-value right there. So what is that stat right there? Where it starts, and then using our alternative graph, what is that oldest green value using alternatives? So what's the probability of that happening? And then we would see that is going to be 76%. So actually that's where the power of the value comes from. Okay, so right here, so essentially the probability of rejecting, and we say rejecting the null given, all right, the alternative is true. Okay, and so let's see, how can we change this power of the test? So if we see the power, let's see, what can we do to increase the power of the test? So how can we get that going up? How can we adjust our different things? So first off, if you notice over here, let's say if we increase our sample size, all right, so n increases. So if I can keep on going up higher like this and keeps on getting bigger, what do you notice about, so if everything else stays the same, what do you notice happens to the power of the test? Well, the power of the test, as we do that, increases. So if I keep on increasing the sample size, all right, we can see that the power test also increases, because as we increase sample size, our actual values become smaller and smaller, and we get closer and closer to the actual value that would be. So it would actually make it easier and easier to actually reject the null, because we know it's going to be false. And so if you increase the sample, increase sample, or increase n, I say, if n increases, all right, what will happen is the power of the test, the power will increase too. So once again, what's the power? The power is the probability of rejecting the null given the alternative is true. Okay, that is the power. Okay, the probability of rejecting the null given that the alternative is true. So if you increase the sample size, the power will increase. So you have greater likelihood that you actually will correctly reject the null when you need to. Now, also what happens if we, I'm gonna put this back down to 50, all right? What happens if our alpha level increases? So let's say we increase this value, okay? So our alpha value increases. What happens to our power? Well, let's go over here. I increased it up here, and what do you know about our power? The power actually appears to also, all right, increase, okay? The power also appears to be increasing. All right, we get 88, we get to a certain point where it doesn't matter anymore. All right, we get 15, but yes, increase the alpha level. All right, you also, there is greater likelihood, all right, that you potentially will reject the null. All right, so that's once again also what happens. So increase the alpha level, you increase the likelihood of rejecting the null, okay, which actually will increase the power. So power will also increase. So once again, you increase the sample size, power increases. Once again, what is the power of the test? The probability of rejecting the null given that the alternative is true. You increase the alpha level, all right, you actually increase the probability of rejecting the null, which obviously will increase the power of the test. Now, as we go over here and as we look at this, what happens if we, our p-value, our alternative p, what happens if this also increases? All right, so if the p-value increases, all right, let's say it gets closer to the actual value, what do you notice happens? All right, it actually, okay, as the p-value gets closer, all right, to the null, the likelihood becomes smaller and smaller. Okay, all right, so if the p-value is farther, all right, away from the null, all right, you increase the likelihood. So if the p-value, um, the alternative p-value, if the alternative p is farther from the null p, it increases the power, increases the power of the test. All right, we say it increases the power of the test. And that makes sense because the farther away, um, well, once again, what's the power of the test? Successfully reaching null because alternative 2. So the farther the alternative is from here, all right, the more likelihood that you probably will get a sample that actually is not going to be in here. So it's probably going to be a greater chance that you're going to actually to reject it. So if the truth is that your p-value is not even close to the null, then obviously you're going to reject it. The closer it is, the power decreases because um, you're actually really close to that. Okay, really close to actually what the true um, parameter is. Okay, and that is what we have there. And from here, we can have our interpretation again, some notes. So the power interpretation, once again, assuming the true mean is, all right, the alternative, there is a whatever probability, so alternative, just state the alternative, probably of finding convincing evidence for the alternate, okay? There is a probability of finding convincing evidence for the alternative and putting in context whatever that may be, okay? And that's what we found there. So that is essentially what the power of test is. Okay, the probability of successfully rejecting the null. All right, uh, assuming that the alternative is true. That's what we have. The truth table, we have once again this. When you have type 1 error, that is when the alternative is true and you reject the null. Okay, that's called type 1 error. Um, and that will be right here. But if you fail to reject it, that would be good. So if the alternative is true, I'm rejecting bad, failing rejecting good. If you know the alternative is true, rejecting a null is good, but failing to reject would be type 2 error. That would be bad. Type 2 error is 1 minus power, and type 1 is alpha. All right, our alpha level. Well, I hope this helps you out in understanding what is the power of the test. And I've got the power of the test. And yeah, and good luck in the rest of your problems.